Hi, my name is Andrew Turner. I teach at Central High School and I'm doing the KCS at Home Summer Edition for Algebra 1. Let's jump into some linear functions, okay? So in middle school, you may have talked a little bit about the idea of slope, which is also known in high school as average rate of change. And we see this all the time, you know, how much money you make per hour, how far you can run in a minute, or there's so many different ways you could think about it. You know, LeBron James scores so many points per game. Anytime you take two ideas, two quantities, and kind of find that unit rate, that is quickly surrounding itself around with the concept of slope. And so a big part of Algebra 1 is, you know, being able to write equations from two-ordered pairs, or if you're given a graph, or if you're given a table. And so let's kind of walk through a scenario where you would be doing those things. So let's say I'm asked to find the slope given 2 points. Well, that's not too bad. We're going to be using that slope formula that's on that other page. And rise over run is connected when you talk about the graphing here. But we're basically saying, okay, the second y minus the first y. -4 minus 6, and that's -10. And then we have, you know, our second x of 5, and we're subtracting the first x, which is -1. And so we have 5 minus -1, that comes out to be 6. And then this simplifies down by dividing both of those values by 2. We get -5/3. So now we could, you know, think about our equation of a line, y equals mx plus b, and we could kind of think, okay, well, we have some information here that we could use. We know the slope now is -5/3. But we just don't know what the y-intercept would be. But we do have a list of points that we could use. You know, we could use -1, 6, or we could use 5, -4 as the x and y values in the problem. So I think what I'm going to use is I'm going to use this first point, -1, 6. So I'm going to replace x with -1, replace y with +6. And now I want to solve for what that y-intercept value would be. So -5 multiply -1, that could simplify just to be, you know, +5/3. -5/3 times -1, that's just going to make it +5/3. And then I want to subtract that 5/3 from one side of the equation to the other side. And then I want to think, well, 6/1 minus 5/3. Really want a common denominator here. So if that's a 3 and this is a 1, I think 3 could be my common denominator. And 18 minus 5 gives me 13/3. So now that I have my y-intercept value, I now know that b is 13/3. And I also know that the slope was -5/3. So now I could go ahead and write my equation. Y equals -5/3 x plus 13/3. So next we're going to look at how we could make that from a graph. So I really love looking at graphs and trying to determine their y equals mx plus b. When I first learned it in 7th or 8th grade, I was really struggling with it. And I remember doing really poorly on the first test, and I had to spend a little extra time working on it, but it felt so good to master it once I did. And so I want to key in on a few things that are important to look for. That y-intercept is always that first point that you're looking for on that y-axis. And for this one, it looks like it's hitting right at 3. So y equals something times x plus 3. So the next thing we want to lock in is the slope. And sometimes you can struggle to find a good point or two in the line. For example, this right here, this is not a good point. That's not a good point. There's several places that it doesn't really go very well through the grid, just like it does here at 0, 3. But I can find, you know, if I really look, you can find another point where you can see that it goes right through these integer values for x and y. So this is -4, -2. That's where that point lies. And so now I can really study what we call the rise over the run. And this is very much connected to the slope formula, y2 minus y1 over x2 minus x1. You know, rise is the y-axis, that's your up and down. And then your x-axis, that's more of your left and right, or your run. And so if we can kind of follow this a little bit, what we can basically do is we can understand that it's going up 1, 2, 3, 4, 5, positive 5, and then it went right 1, 2, 3, 4. And then it's also got the x there for your input spot. So this creates your mx plus b, or your equation for the line. And so when we look at something from a table, we may have to do kind of a combination of what we just talked about a minute ago. So we're going to have to first calculate what is that rate of change. Let's kind of think of this as like your x1, y1. Sorry, that is not correct. Your x1, y1, and then this is your x2, y2. So once we have labeled our points, we can then kind of start thinking, well, what would y2 minus y1 be? What is 17 minus 8? And same thing here, what is x2 minus x1? In this case, 2 minus 1. So when we calculate this, 17 minus 8 is 9, 2 minus 1 is 1, and that slope just calculated to be 9. So we know that our equation is something like y equals 9x plus b. We don't really know that y-intercept value yet. Okay, it's kind of an unknown value that we need to kind of determine. And so we now have a whole list of points that we could use here as input to kind of figure out, well, what would that y-intercept need to be? So I really like the smaller numbers. For example, when I plug in the number 1 for x, I should get out, and I should have probably labeled this, instead of y, maybe I'll label it f of x. That's really the same thing. Y and f of x, those are really synonymous terms. And so 8 is more of my output value. And so I really need to kind of figure out, well, what would that make my y-intercept? So let's think. 8 equals 9 times 1, which is 9. And really, 9 plus what number is 8? You know, that would have to be a negative number. You'd have to subtract 1 from 9 to land on 8. And so when I solve for b, it looks like it's a negative value. So for this table, I believe I would say, well, this has to be 9x minus 1. And if you think about it, 4 times 9, 36. But if you subtract the 1, you're going to get that 35 there. Or 6 times 9 would be 54 minus 1, 53. So basically, it's kind of like you take your x values, multiply them by 9, but it's always 1 less than that. 2 times 9 would be 18, minus 1 is 17. So you always want to really make sure that the input-output part is really flowing and going in correctly to make the table. So the next thing is, we have slope-intercept form. That's the mx plus b style equation that we just talked about. But standard form is a different way of writing the equation. It's more based on having x and y, your input values and your output values, on the same side. So this example here kind of talks about how you can solve for y, basically transforming standard form into the slope-intercept form model to make it easier to graph. So let's do an example here. 3x minus 4y equals negative 12. So the first thing I want to do is I want to try to think about moving this 3x term from the left side to the right side. In fact, in the first one, they subtracted 2x, and that's what made it all cancel on the left. So I want to subtract 3x here. Negative 4y equals negative 3x minus 12. These are not like terms, so I do not want to say that's negative 15 or 9. You don't want to put those together because they don't have both x's, or they don't both have, they're not both constants, meaning they don't have an x on it. So now I want to divide this value over to the other side, because when you're moving things around in an equation, you always want to think about what the opposite operation would be of what it's currently doing. Negative 4y, you're currently multiplying, so we want to undo that by dividing it to the other side. So we have some simplification here. Negative divided by negative, that's positive 3/4 x there, it doesn't change. And then negative 12 divided negative 4, that makes positive 3. So now let's graph that on our coordinate plane here, starting with the y-intercept of 3. 3 would be that very first point that we want to plot on the y-axis.
And then the slope part, it looks like this is going up 3 and right 4. So it's a positive slope. We want to think of it as going up from left to right. So this is going up 3 and right 4 for another point. And I can even backtrack that backwards a little bit and say I could go down 3 and left 4 to kind of find another very precise point that line would hit. So now I've got a few lines here. I think I could go ahead and connect my 3 points that I know are on my graph. And just to really make sure we understand what graphing is, this is the point 1, 2, 3, 4, 1, 2, 3, 4, 5, 6. This is the point 4, 6. Meaning that if you were to replace x with 4 and y with 6, it would give you exactly negative 12. And so we're kind of mapping out all of the x, y values that go in and create negative 12, and we get a picture that forms. So let's talk a little bit about multiple representation. Multiple representation, we could have graphs of a situation, we could have tables, we could have a list of points, we could have a mapping. There's all different types of ways to classify information that we record. And so, for example, Tanya and Milo bike from the park at the same time, and Tanya is 4 miles from home. And she's heading towards her house, so that distance is decreasing over time until she finally reaches her house. What looks like it takes about 20 minutes to do so. Well, Milo, she's 3 miles from his house. Okay, so time hadn't started yet, but 3 miles away. And then they start walking until they reach the house. And so you can kind of calculate that they're going different speeds, basically. Tanya, she is traveling 20 minutes to go 4 miles. And I really have that upside down because we really want to think about it in the slope formula, y minus y over x minus x. And so I want to think about, well, I went 4 miles, thinking about miles per hour or feet per second. You always have the distance unit first. So you basically go 4 miles every time you have 20 minutes go by. And so you can kind of simplify this down to kind of figure out like how fast you're moving. 4 over 20, that's 1/5. And so that's basically like 1 mile every 5 minutes. And so this rate of change, we may kind of think of it differently. It looks like, they traveled 3 miles, but it took 10 minutes. And so we can kind of think, okay, is 1 over 5 less than or greater than 3 over 10? 3 over 10 is greater. And so it looks like Milo is going just a little bit faster in that situation. Let's talk about solving equations with the few moments that we have left. We're going to talk a little bit about using properties to kind of solve for x here. And so the first thing I want to talk about is you have the distribution process. When we use distribution as our first step, we should see this as 6x plus 3 equals 4x plus 6. And then we want to start combining like terms using the subtraction property. I'm actually going to use it twice here. I'm going to subtract 4x from one side to the other. That gives me 2x. It's the first time I do it. And then I also want to combine the 3 over with the 6. And so that ends up being 3 on the right. And then the last thing I want to do is use the division property to kind of finish this out and say that my final answer is 3 over 2. About 1/2. So let's try one last one. First thing I want to consider is simplification. For example, 1/2 minus 6, that is negative 5.5. And I see 2 plus 1, that makes 3. So I want to do some quick simplification there. I want to use the subtraction property to combine the 3 and the negative 5.5 to get negative 8.5. And then, like the other problem, let's finish out by getting x by itself. Divide 2 to the other side, and we get negative 4.25. So I'm going to jump into the next video. I'll see you in just a minute.